Mathematics in science is not just about calculation, it is a language for thinking. Equations are not just calculations, they describe relationships between quantities. Always understand the situation and the quantities first. Equations will act as helpful guides. Distance, time, and velocity helps predict motion. Mathematics helps scientists think clearly. One of science's greatest strengths is prediction. It helps scientists predict motion, chemical reactions, population growth, and even energy changes before they happen. That is, scientists can anticipate what will happen under new conditions even before performing an experiment. Now, let's learn three highly important terms: laws, theory, and principle. Be sure to know the difference. A scientific law describes a regular pattern in nature. For example, Newton's laws describe motion. A scientific theory explains why those patterns happen. For example, atomic theory explains how matter behaves. A principle is a broad guiding idea used in many situations. For example, conservation of energy. Remember, laws describe, theories explain, and principles guide. Which one do you find most interesting? A theory is not a guess. Science has reliable laws and theories. They are reasoned expectations, and it gives us a superpower: prediction. Using scientific understanding, we can predict weather and motion with incredible accuracy. Every prediction is rooted in evidence, measurements, and patterns. When predictions fail, scientists don't rely on opinions. They re-examine their assumptions and evidence. They improve models and revise theories based on new evidence. This ability to change makes science reliable and powerful. If you want to predict the weather, simply saying the clouds look dark is not enough. A scientist will ask for measurable data. What is the exact humidity today? What is the wind speed and direction? What happened previously under similar conditions? But why do weather forecasts sometimes go wrong? Weather depends on many changing factors, and very tiny differences in temperature, pressure, or humidity can grow over time and produce completely different weather later. This is exactly why forecasts are reliable for a few days but become much less certain further into the future. Using the same logical questioning, scientists bust viral myths. Some people claim food becomes bad and harmful during an solar eclipse. By asking measurable questions like, does the temperature change significantly, or does food rot just by being in a regular shadow? We can easily prove there is no physical, chemical, or biological mechanism or scientific evidence to support that myth. Are you ready to test your own scientific thinking? In our next lesson, we will discuss about estimation. Subscribe and keep exploring. Happy exploring!